Welcome back to the Installer Plaza, sponsored by our very good friends at Vaillant. And this session is really about heat pump FAQs. Accurate and comprehensive designs are crucial for delivering high quality heat pump installations. Yet within the industry, there are ongoing debates about the best way to implement and integrate certain products within heating systems. As the UK pushes towards widespread adoption of heat pumps, it's clear that different property types will require tailored design approaches. So some of the key questions include, can heat pumps effectively work with microbore pipe? Should heat pump systems be zoned? Lots and lots more questions. Well, we're going to explore these topics and many more. And I'm delighted and excited to welcome an expert panel joining us here this morning. I'm going to ask them to introduce them to you, and starting with the gentleman on my left-hand side. Who are you? Where do you come from?
Morning, everyone. My name is Iasonas, and I'm the head of technical support for the residential group within Mitsubishi Electric UK.
Morning, everybody. I'm Craig Dolan. I'm the current chair of the Heat Pump Association. I'm also senior product manager for Dimplex for heat pumps and hot water.
Hi there, I'm Leah Robson. I run an installation company called Your Energy, Your Way.
Hi, good morning. My name is Michael Dungworth. I'm head of technical at NIBE Energy Systems UK.
Hi, I'm Stuart Kerr. I'm the OEM Key Account Manager for Danfoss Climate Solutions.
Thank you. Just remind you all just to hold those microphones nice and close when you're speaking. Thank you. Welcome. And welcome to all of you. And if you have a question or a comment you'd like to make through the session, then please feel free. Just put your hands up. We'll come to you to get your comments. Iasonas, let me start with you. You're the closest. Can heat pumps work with microbore pipe?
They absolutely can. It takes a level of diligence to be carried out and a lot of creative thinking from the installers to make sure that they take into consideration all the parameters, such as the existing microbore, what we mean by microbore pipework, the capabilities of the selected product that are going to be delivering heat to the properties. Also, they need to understand how much disruption they need to be causing to the dwelling that they're going to be replacing a boiler system. We've recently published a white paper with SNG, Sovereign Network Group, that covers in extensive detail how you can implement a heat pump technology by replacing a boiler system without, by limiting the disruption that you cause to the dwelling. This study is in extensive detail, and it goes in a step-by-step process on how this can be implemented successfully. So, yes, they absolutely can.
And how can people get hold of this study?
It's all over our social media, all over our websites. Literally, by typing microbore and EcoDan or microbore Mitsubishi Electric, you should be able to find it. It's got a very, very detailed flow chart that shows exactly what you need to consider, all the parameters that would play a massive role into this transition, into this smooth transition towards renewable technology from a boiler heating system.
Brilliant, thank you. Leah, let me come to you. What do you do in properties with microbore?
So we do some calculations to start off with. So really you have to have some understanding of hydronics, so how water flows about a system and how it carries heat. So I would really recommend getting on a course, finding this kind of stuff out. So Warmer Academy do a fantastic course. Heat Geek do fantastic courses. You've got to get that understanding into your head of what water does as it flows through a system and how it carries heat. And once you've got that knowledge, then it's about applying it in the specific house that you're in. So you're not just taking the pipe work into account, it's the radiators, it's the TRVs, it's the distances, it's things like, I mean, we've been caught out recently. Customer told us about halfway through, well, we worked out partway through the install that their house used to be two separate houses. They'd smushed it into one. Now, if we'd known that at the beginning, we would have been much more skeptical about what the pipe work was like. So, you know, sometimes it's just going that extra level of detail with the customer. What do they know about when that extension was built, or the plumber that they maybe had round to do that? Because, you know, we've all lifted up a floorboard and sworn loudly because we found something that we didn't expect. So you can do all the calculations in the world, but, you know, then
it's never cash, is it? Never cash.
No, exactly. No, haven't ever. No.
But the courses, of course, are difficult sometimes because it means you've got to take time off to do that. But it's vital to do it. Brilliant. Okay, now, Craig, let me turn to you. To get to mass market heat pumps, are we going to have to accept lower COPs for some buildings?
No. Maybe.
Right, we'll move on then.
It depends, which is the
Yeah.
great answer that is the answer for everything. So, COPs,
Yep.
coefficient of performance, varies throughout the year, and it varies on how the user is using it. It varies on a lot of things. So, will we have to accept lower COPs? No. Will we get them? Probably. But they vary over a period of time. Like when it's -3 and the heat pump has to work harder to keep the warmth in the house, the COP will be lower than when it's 5 degrees. But if we take 2 degrees as an outside air example, like that's the typical winter temperature in the UK. People look out the window, they see frost on the floor, they feel cold, they turn the heating up. The house is at temperature, but it's about the feeling. So it's interesting that in heat pump land, we're all very, very much focused on COPs and SCOPs. Anyone know the measured efficiency of their boiler at the moment? Anyone?
That's a no then.
No. So the measured efficiency of my heat pump at the moment is 5. Yeah, so it's been in over 3 winters. It's 5 in heating and it's 3.2 in hot water. I know that because I'm a geek and I'm a nerd and I want to know. If my mum had a heat pump, she wouldn't care. She wants hot water and she wants heating. So
Does she care that you're a geek though?
Probably.
Yeah.
Someone's got to. So it's kind of like we don't have to accept them. We shouldn't design them in. We should design for efficiency. The gas price shock that has hit our energy bills at the moment that we're still living through has brought efficiency to the forefront. And you know, when we moved from non-condensing boilers to condensing boilers, we should have moved to low temperature heating systems, and we didn't. 2 decades have passed and we're only just starting to get round to weather compensation in most market. So heat pumps are a little bit of a culture shock because we're doing all the things that we should have done over the last 2 decades and didn't. So we're catching up on ourselves.
Thank you. Does anybody have any questions or comments so far? Yes, hang on a second. Can I borrow your microphone? Yes. Thank you.
Hi there, Andrew Webster. Just a question about the
I
microbore.
can't hear myself coming through.
What flow velocity would you expect?
Just hold that nice and close, that's it.
What flow velocity would you expect to have with microbore piping?
So this would obviously depend on the products that you're trying to implement in this transition. I'm going to speak for our products that I'm more familiar with. Within our R290 product range, we do a wide range all the way from 5 kilowatts down up to 12 kilowatt units. So obviously varying flow rate would require different flow velocities through the pipework. And getting back to my initial point about what we define as microbore pipework, it goes all the way from 6 millimeter up to 15 millimeter. So there is a range of velocities that we're looking at. This study that I was referring to earlier, it goes into the nitty-gritty of this transition, so you can even see what to expect in terms of velocities, in terms of flow rates, in terms of temperature differentials that you need to be meeting, and the capabilities of the products. And this is up to the understanding of the installer to make sure that the transition is going to be smooth. So I don't have a direct answer in terms of the velocities as in a value, but it's down to the level of diligence to make sure that we're familiar with the products that we're trying to implement into this transition. So it depends again.
Pass that back. Lovely. Thank you. Anybody else just before we carry on? Okay, I'm going to carry on. Stuart and Michael, actually, should we zone heat pump systems? What's your feeling? Stuart, you're blowing out through your cheeks there. Do you want me to come back to you? He's having a think. Go on.
It depends.
I think there's an
Nice
argument.
and close.
Sorry, I think there's an argument for both, really. You know, we at NIBE and sort of the Nordic Swedish way is to have quite an open loop circuit, you know, but certainly having zones depending on emitter type is certainly something that needs to be taken into consideration. It can be. We do applications for varied temperatures, emitters at higher flow temperatures, you know, and underflow at lower flow temperatures. So that certainly is an option. The thing is the controls. You know, we need to ensure that the control circuit is matching the hydronic circuit as well. So we've got good control of these zones and ensuring that the product's working to its most efficient.
Stuart, you could say what he said, or
No, I think
nice and close. Nice.
sorry. I think with the balancing side and the zone side, like you said, there's arguments for both either way. With the balancing side, you're looking at the TRVs, for instance. On a gas boilered system, if it's balanced correctly, you can save up to 90 cubic square metres of gas a month. Same principle can be used in the heat pump situation. If the TRVs or the balancing valves are in there as well, you've got to think about the client's comfort. So there's a COP rating that you'll think, right, okay, so the performance of the heat pump has to be its highest, but is that at the detriment to the end user? Because are all the rooms going to be a constant 19, 20 degrees? Do you actually want that to be the thing? Or do you want to be able to zone them off so you can turn 3 or 4 rooms off if you're not in there and put 3 on if you are? So it's a pretty open question, really. And again, it's what preference the installer has. Do they want to do a control downstairs, control upstairs, or do they want to control every room individually?
Did you want to say something, Leah?
Yeah, I mean, we tend to be quite guided by the customer at the same time as not letting the customer do anything too silly. So if they have a house that has kind of like an L-shaped house with quite a separate wing, some of our customers have nice big houses, that they don't use very often, and that house is kind of quite contained into 2 parts, and it makes a lot of sense to zone. But in general, we try and avoid zoning. We want to keep the system as open as possible, make as much of the house as warm as possible for as much of the time. Because if the house isn't well compartmentalized, what happens is that the heat from the area that you are heating is quick to flow to where you're not heating. So then all that happens is the emitters that you've sized to heat part of the building are actually having to heat the other part of the building that they weren't really sized for.
So you do design sort of zone systems?
Occasionally, in a specific kind of set of circumstances where, yeah, it's what the customer really wants and we can make it work.
Right, thank you. Craig, I mean, you kind of said, well, depends. I mean, did you want to add anything to what we've heard from Craig?
Well, I was going to support Leah, really. It depends what the customer would like.
Yeah.
You know, we're heating people's homes. You can do what's best to get the best COP or efficiency for the heat pump, but you need to make sure that aligns with the customer's needs. There's no point in having a super efficient product if the consumer's not happy. So if the consumer wants upstairs and downstairs zoning, then it's down to the skill of the heating engineer to zone the system and balance the system accordingly and make sure that people are warm and comfortable. We're only heating water, and we've just got to make sure that we're heating homes and making sure people are warm and comfortable.
I'll come to you in a second. Michael, what's your view? Just in terms about the zoning and so on and so forth.
Again, I think the customer needs to be...
need to focus on the customer.
Needs to focus on the customer, really, and the installer then would be product selection or, you know, specific for that property, because every property is different, you know, and that can be... And every customer's different as well, and people have different, what they would consider comfort level. So that's first and foremost. Then it bleeds into what selection, what product application do we need to go for? What is the current, if it's a retrofit, is it a new build? There's all kind of questions around that where it might change the dynamic of that installation or again that product selection.
Yeah, Iasonas, you wanted to come in.
Yeah, just to add a few more bits that my co-host here covered it pretty nicely, but for me, it's also to do with the technology that we've got into the house. Obviously, if we've got an underfloor heating application, it would require different parameters to work efficiently compared to a radiator system. And also, very important for, I think some of you mentioned controls there, and making sure that we're not conflicting between the heat pump controls and the emitter controls is actually absolutely essential, because if you conflict and you have a zoning system, then you can have some very, very bad experience with a heat pump application.
Thank you. Stuart, does anybody else have any questions? Yes, look, there's a man, his arms wide open. Oh, thank you, Iasonas.
So something we've been playing with recently is to take all the TRVs and the lock shields off completely. Looking at intermittent heat, where we heat the house up 8 o'clock in the morning, we can shut a couple of doors, and if we switch the TRVs off in those rooms, they won't get hot. And they don't get hot because we switch the heating off at 9 o'clock when we go to work. When we move on to continuous heating, and our heat is being supplied 24 hours a day, as Ria was saying, it doesn't matter how clever you are, trying to keep the door shut, the heat will eventually get into that cold room. So why just not give in to that? If we set the flow rate, if we've got a 5 kilowatt house and we set the flow rate for 5 kilowatt going into the house and we take all the lock shields off, within a week, all of those rooms are going to be at the same temperature and they're going to stay at the same temperature all the time because the heat will just move to the colder areas. So why don't we just abandon lock shields and flow rates on the emitters altogether and just concentrate on the flow rate coming out the heat source?
Who'd like to pick that up? Yeah.
Has he got one on sport? No? Has he got a question on sport instead?
I've got a
No?
question on sport. Well, let's switch to religion. It'd be a lot easier, wouldn't it, probably? Come on, panel, you're
Okay,
expert.
so yes, you can do that, and then, but you need to make sure that if you are going to do that, you have really spoken to the consumer and made sure that the consumer understands why you are suggesting what you are suggesting, how it is going to work, what they need to do, and what the potential outcomes are going to be. Like, open loop systems are great, but you need to make sure that you've taken the consumer with you, because from an engineering point of view, bang on, you're correct. From a consumer point of view, yeah, you might be a bit off, but you need to make, like, we're going into people's homes, right? It's quite intrusive. People
they
safe
need
spot.
education as well, don't they? Because they don't know.
They need education, but you're in their home, so you need to do polite education. It's like,
Correct.
this is why I would suggest that you do this. These are the reasons that I would suggest it. And you can explain about heat leakage from unheated rooms to heated rooms and things like that. The challenge that we face with that is,
Can I borrow that again?
I don't know for how long we've told everybody if they want to save energy, they turn the TRVs down on their radiators. Every winter we say that. So that is culturally ingrained. So you're going to have to find somebody who's open to listening to that and understands. And that's tough because there's people that struggle. And if you go into their house and say, you're taking away some agency or some control in TRVs, then it's probably not going to go down too well. But there'll be other households probably investing in it that will be open to that. But you've got to be consumer-led and you've got to be able to flex for the property and for the consumer. So
I'll give you the microphone back. I wanted to ask, are you an installer? Have you been an installer?
I used to be.
Used to be. So what was your experience then?
So we're part of the gang that push the envelope and don't listen to anybody else and just play with stuff to see what works.
That works.
That works, yeah. And we are coming to the conclusion that you're absolutely right about educating the customer. In a small property, personally, I don't take any nonsense from the customer and I tell them what they're going to have. Because if you listen to the customer, they'll want to...
You wouldn't be coming back to me.
They don't understand that we don't want TRVs and we don't want zones and the thing's got to put the energy somewhere. So why not put it in the room? Why stick it in a buffer that's insulated that achieves absolutely nothing? Why not? You've got to pay for it anyway, so why not do something useful with it? Educating the customer, I'm absolutely with you on there, and there definitely are places where you need zones. But with small properties, it's one less thing to fit, a buffer. I am the antichrist of buffers, not that that's really relevant here, but I mean, we don't need buffers if we design properly. And I think, just going back to the microbore thing, I think microbore should be a phrase that's taken out of our vocabulary. It's just another piece of pipe. And if we apply the same maths to that piece of pipe as that piece of pipe, it either will or it won't do the flow rates that you need. And to answer your question, and I don't know why they faffed around saying what they were saying, there's a maximum velocity you're allowed, and as long as you're under that, it's fine. Yeah. So I'm going to go and sit up there and help these guys give you some answers.
Kimbo, thank you very much. We couldn't afford you, I don't think. But there you are.
So I'm very glad that you're bold enough to tell customers what you did. It's like, I've got a great story of an old lady with a weather compensation curve. So we had an intelligent weather comp curve, and her running costs were through the roof, and we couldn't figure out why. Everything was set up perfectly. We turned up one day, and she forgot that we were there coming, and she'd taken her, it was washing day, so she wanted to wash her things. She'd taken her control off the wall and put it in the fridge, right? Genius, right? The heat pump system thought it was 4 degrees in the house. The radiators were bouncing off the wall. She did our washing once a week. Guess how long it takes for the heat curve to adapt? A week. So like it was going all the way up and then all the way down. So like we screwed it to the wall and we gave her a dryer, like sorted. But there's unintended consequences like that. But yeah, open loop is a way.
How important is weather compensation?
No, it is important, and it's getting more efficiency from the building, because really basic way of understanding, if you're cooking potatoes or pasta or something on the stove, you don't press the boost button and leave it. You press the boost button, it comes up to boil, and then you turn it down until it's simmering. That's what weather comp is in very simple terms. It's some boost function when it's colder, and then it goes down and it just tickles the heating along.
We'll get you on next year, Kimmo, if that's all right. If you've still got any customers left, that's the only thing. Craig, position as a trade association on topics like zoning. What's the position of the trade association?
So what we do as a trade association is we do things like this, but less publicly, and we go through and we work through technical documentation, and we bring through guidance, and it is like we've got over 200 installer members and like over 300 members, and we have a technical working group, and we get people involved, and we tackle different issues like a commissioning checklist that we've done recently. We got some feedback, so we're changing that. We go through and we work with other trade associations like BEMA, who've got a controls group, and we try to come to a consensus, and we try to build together documents that say, if you are going to zone, here's the best way to do it. If you are going to use a buffer, this is the best way to do it. If you're not, this is the way to do it. And it's kind of pointing people towards light touch guidance, but then directing them to training materials where they can go and learn further. And it's all about being that light introduction, and then directing people to areas to find out more and to get more comfortable and more competent in that subject. Brilliant, thank you.
Stuart, Michael, let me come to you. These are the FAQs that we received, okay, or we looked at. How do we select the right emitters? Radiators, underfloor, a mix? What's your view?
My personal view is it depends on
nice and close, sorry.
It depends on the property. It depends on the house.
Right.
If it's a brand new build, I would suggest underfloor heating all day long, because your floor's the emitter. It's the biggest space in the house. It will emit all day long. Who wants a huge K3 radiator in a new build? If it's an older house, 80s, is it insulated correctly? Have all the necessary details been on that house to make sure that it's good for a heat pump? Is it going to be efficient for a heat pump? Is it going to be efficient to put oversized radiators in, or is the heat loss too much? So for me, I've been in plumbing and heating 30 odd years. I've been on the merchant side, and the amount of customers that come in, or engineers, that don't really plan it. They just go, that's a 6x18, and they just ad hoc it all the way around, and it's finger in the air. What can I put in now to save a bit of money? That's basically what it is. But nowadays it's a little bit more technical. You've got to make sure that the house is right and the property values are right. So
everyone's waiting to jump in. Michael, let me come to you.
Yeah. I would mirror what Stuart has said. Yeah, I think quite often what we would see or would anticipate is that there's a room by room calculation to select the best and the most applicable emitter for that room. Again, what Stuart was saying regarding the underfloor heating is the more surface area of heat emitted we've got, the more heat we're going to get into the building, and then there's a question about how much heat are we going to lose room by room as well, and across so that's the calculation. We need to make sure we're balancing them too, and then that determines either what emitter, whether it's K2, and underfloor heating, and balancing, and then you move into zones and controls, and so that's that all-encompassing application that starts at the grassroots of entering somebody's property.
Leah, did you want to make a comment?
Yeah, I was just going to say one thing that confused me in the past, and I know other people have been confused about it when it comes to radiators, is we talk about 2 different types of delta T, and we talk about them interchangeably, and we don't necessarily always explain. So when you're sizing radiators to go, or underfloor heating to go into a house, you want to think about the delta T that you're going to have between your flow temperature from the heat pump and the return temperature from the heat pump, and that will typically be 5 degrees. But then you're also talking about when you're sizing your radiators, you're converting from the delta T of 50 that's given on standard radiator tables to to the delta T of whatever temperature you're designing your heat pump system to. And that was never explained to me for a long while, and people would always be delta T, so just watch out for that. Two different types of delta T, one about the flow and return from the heat pump, the other is about how you adjust radiators for the flow temperature that you've got in your particular design.
Brilliant, thank you. Yes, sir.
I was just going to add that, that we have seen too much progress on the technology that's out there, and there's technology that can model and you can simulate what you're going to see in the house, what you're going to see in a property, so that you can see how the heat distribution is actually going to take place into each property. Obviously, if you apply that onto a mass market model, going back to what you asked us earlier, if developers from the new build perspective standardize the house types that they're going to be doing, there it is, there it goes. You only need to do one study for one house type, then you standardize across the board. You make selections very, very straightforward. Going back to the tools that are available out there, 6 years ago, there were no tools to provide 3D simulations or even 2D simulations. Now that AI kicks into this industry, you can very, very easily use a tablet to scan a property dwelling, see how the heat is going to get distributed in each room, and make your selection on the heat emitters. So it's a lot more straightforward than what it used to be, less time consuming as well.
Leah.
Oh, just one other thing on emitters. Don't just think about the emitters, think about the TRVs. So we do put TRVs in some rooms, and customers, as you know, customers are always right, we've talked about that already, but they choose a radiator they might like, and they'll also sometimes want to choose a TRV that they might like, and sometimes you lose that argument, but you really don't want them to choose particular TRVs that have very small holes in them, because if you've got a TRV that's not allowing flow through the system, you might have sized your pipework all beautifully, you might have a fantastic radiator that meets the heat loss of the room, but then you're trying to push water into that radiator through a very small hole, and it's not a good idea. So watch out for that one too.
Customer's always right, remember? So I'm going to ask you, have you always worked over here, or have you worked at home in Greece as well? Because you'd be very different situation in Greece.
Yeah, it was the extreme opposite. Yeah, it was the extreme opposite.
Yeah.
Right there, it's air conditioning, air to air all the way. Yeah. While when I made the transition, it was an eye-opening experience. Heating systems can be very, very different across Europe. I can speak for myself. What I've seen back there wasn't regulated at all, and I moved into an industry that everything is regulated. There's rules and conditions that you need to be meeting. There is the regulators such as MCS that you need to comply with. In Southern European countries, it's not like this. So, and this is, it's a chicken and egg conversation, because back there you have the flexibility to improvise, while right here you need to comply with a lot of different pieces of regulations. So yeah, I don't know what's better. I clearly don't know what's better, but I prefer structure. So right here we do have the tools. We know what we need to be designing to, what we need to be meeting. So it's just a matter of optimizing our tools to help our customers and installers do the job as effectively as possible.
Brilliant. So for all of you, another FAQ, if you like. One of the hottest topics in heat pumps is glycol versus antifreeze valves. What's your advice? Everyone's sighing over here.
Depending which technology we're talking about, certainly from NIBE's perspective, is ground source. It's a requirement. There's no question about that. We need that in the collectors. From an air source perspective, NIBE's control system doesn't require it. There are some installers out there that will fit that, and obviously that comes with its own sort of territory of testing, maintaining, ensuring water quality. If you're in an area where you might have elongated power cuts or something like that, you might want to think about it, if you're quite rural. But as a whole, NIBE systems don't require glycol to be installed, and I think if you maintain good water quality and maintenance and servicing, then there should be a carefree sort of application.
Anybody else? Yeah, great.
So on this point, the manufacturer's instructions are king. You need to look at the product that you're installing and check what the manufacturer's instructions say, because they will give you the guidance that are related to the warranties and guarantees to that product. If you are designing ground source heat pumps, definitely need some form of glycol that in the ground loop. That makes perfect sense. You need to water quality is the silent thing in all heating systems that needs focus. If you are doing a well-designed system and you are insulating the pipe correctly and you are trunking the pipe correctly and you are minimizing external pipe run correctly, and there is a robust electrical connection, then you shouldn't really need antifreeze protection. All heat pumps on the market, bold claim here, have some sort of antifreeze protection built in, which will circulate the pump when the heating water drops below a certain temperature. Some heating pump systems have an inline heater as part of them, and when that will come on as an airbag, if you like, to heat the water up to make sure that doesn't freeze. The worst case scenario is, it's deepest, darkest Scotland. There's a power cut that's lasting for more than 3 days, and then that's when you'll need the protection. Whether you choose to do Glycol or antifreeze valves depends on the manufacturer's guidance for those appliances, and as long as you've put some thought and some upfront effort into the external pipework and the risk assessment around that, then you should be fine. Like, if arguably you could go underground with the pipework, which is what they tend to do in Germany and in other European countries, but as long as you've insulated the pipe, trunked it, and you've minimised it as much as possible, you should be fine 99% of the time.
And just to say that power cuts are available in other parts of the UK as well.
Yeah.
Okay.
Norfolk as well, and Cornwall, Devon.
Leah, did you want to come in there?
Yeah, just a couple of really practical things. Where we do put antifreeze protection on, we only put one antifreeze valve. I can't see an argument for putting on two, although I got picked up on that on my MCS audit, so I don't know if they're listening right now, but anyway, I think just one. Also, if you do put Glycol in the system, remember that changes the characteristics of the water, so you're going to need to think about your underfloor heating and possibly even your emitter design if you've got Glycol that actually goes right the way through the whole system if you're not separating that out.
You said you got picked up in your MCS audit. What was the outcome of that?
I had to fit an extra antifreeze valve on that job just to keep them quiet.
And how did the customer react?
We just told them we had to fix the phalange,
Anyone from MCS? No. Okay. Anybody else want to comment on that at all?
I just wanted to add that the weather conditions do play a role in this. Obviously, 15 years ago, the yearly mean temperatures were significantly lower to what they are at the moment. So back then, antifreeze solution would be the way to go. But as we're progressing, and unfortunately, as a result of the climate change, we're now seeing higher temperatures as well. So this is where antifreeze protection, we can have antifreeze valves to work more effectively without having these headaches that we used to have in the past. Obviously, again, it's a level of diligence that we all need to have, and the manufacturers, I agree, they play a massive role in this. So from our perspective, we are flexible in this, but we're just going to highlight with our customers where is the application and what is it that they're going to be compromising if they go one way or the other.
Just to add on that, like, if you do choose to use Glycol, you need to leave a clear note somewhere that there is Glycol in the system, because if they choose to get their house decorated and the painter and decorator takes the radiator off the wall and paints behind it and then puts it back on and adds water into the system, you've changed the makeup of the Glycol.
Right, okay.
You've introduced air, bacteria, and other things. So, like, you just need to make sure
So
consumer handover.
Customers won't think of that, will they?
Customers won't think about it, but you need to let them know that you've done it, and you need to make it obvious on the cylinder or somewhere that there is Glycol in the system, just to as that aide memoire. Because if somebody comes in cold and they don't know that, like, it could cause a service call out, and then the service engineer isn't going to know.
What the situation
And when they do a water quality
yeah.
test, it's going to be all whoppy. So.
Okay. Anybody else? I'm looking at you, but anybody else got any questions or comments they'd like to make? Yes, at the back there. Can I take that again? Yes, thanks. Just tell us what you do and what your interest, if you like.
Yeah, I'm Colin Timmins from National Energy Action, which is the fuel poverty charity.
It's on.
It's on.
Hold it nice and close to your mouth.
I think, like the chap at the front, we've been trying to push the envelope and see what works, but we've been doing it in the Energy House at Salford University. So if anyone wants to see some data on what happens to the system with different applications, we've got a session at 2 o'clock, so we'll be going through that, which is quite interesting. But my question is, there's 35,000 heat pumps been installed under the Eco4 grant scheme. Now, they're being put into the homes of fuel-poor households who probably can't afford to use their gas heating system that they've got. We've got electricity 4 times as expensive as gas per kilowatt hour at the moment. So what's the approach that people should be taking in those type of applications?
Leah.
I mean, you need a really, really good installer who knows how to make that system. What are you saying? Yours has got a SCOP of 5. You also need to think about, the problem is they probably haven't got smart meters. They're probably on coin in the meter, aren't they? So they're not even on kind of smart tariffs to make it cheaper. So really your only option is to get the absolute very lowest flow temperature so that the system runs as efficiently as it possibly can, so that they're making the most of every penny. I'm not sure that's necessarily the standard approach of Eco4 installers, but who am I to say?
It's a challenge on Eco because the way that it's set up isn't necessarily set up to install the most robust or the most efficient system. It's installing the most systems. Minister Van Boele is on top of that. We've seen what's happened with, or if you haven't seen, there's been quite a bad fallout from solid wall installation, and that has pulled everything under review. Some of the installations on Eco aren't where they need to be, and arguably they weren't where they need to be when they were fitting gas products as well. So it's kind of it's a tough thing to go at, and you're right, because some people who are the most vulnerable are being stung, and there's lots going on in the background. I know you're working on it. The Salford House Heat Pump Association are in open conversations with DESNES and what we can do to improve Eco and how we can improve Eco installations. But yeah, controls and handover are really, really critical, and that area is left wanting under Eco installations. There's very little handover and very little understanding, and you know, people are trying to minimise the use of their heat pump, so they're doing it in an on-off fashion. So they're turning it on and it's running peak for 45 minutes. They're seeing that it's costing them a lot of money. They're turning it off, and then that handover is really, really important. That's a tough area.
Yeah, did you want to come in and say something as well? Yeah.
I think it's just as important when we look from an installer perspective as it is from a manufacturer's perspective to have the ability to self-help for the consumer. So, you know, whether that's videos, whether that's documentation that you can get readily available from internet, you need to be accessible. That information on how to use that system that you've got in your property the most efficiently and understand how it works. And it may or may not, you may be a geek like such as yourself and myself, where you would interrogate that to its nth degree, but you may not do, you know, but having the top line information, and they won't, but having the top line information just to know how to improve and make them small efficiencies will ultimately save you money.
Yeah. The challenge that we have with Eco is it's the wonderful phrase of lowest cost of compliance, and it will be all right. If somebody comes in and says it will be all right, probably need to think about it a little bit more. We need to move away from lowest cost of compliance and best or longest term value, I would argue, but it's tough.
It leads on to a question I've got here, really. How do we support installers when they have questions about best practice for design and installation? What's the best way of supporting this?
I think the best courses that are out there actually kind of include that as an element of the course. So, you know, part of the ongoing process is that you're talking with other people that you know that have been on the course that you're able to ask questions of. There are also some fantastic installers out there who are willing to mentor other installers, and you know, that's a great thing to be.
How do people find out about them?
Go and drink in the bar. You probably missed your opportunity last night, to be honest. But a lot of that is just happening informally, just through networks as people get to know each other.
Right.
But yeah, it's definitely got to be an ongoing process.
The best way to learn is through peer-to-peer. Like you can go in a classroom and you can get to a level of understanding, but then that doesn't necessarily give you competence on the front line. And then most training agencies will do a bit like a dating service. They will say, oh, well, there's this guy in your area who does it. Maybe you can give them a call. I know on a lot of training they exchange numbers and stuff, so they can help each other out. You've got the Heat Geek network. I know Nathan Gamblin, who I just saw wander off. He's very he's champion peer-to-peer learning. It's sometimes you need a reassuring hand the first couple of times you're doing it, and the best way to have that is to have someone with a little bit more experience giving you the nudge or the reassurance. So it's like getting in the classroom is part of it, but it's not the all of it. It will never be the all of it.
So for me, it's also a combination of the training that's available out there, bespoke training on its products. We've got a training offering that is widely available. We've got an LCL's accredited course as well that people can sign up for. And also down to the application side, it's how you benefit from the supporting functions that manufacturers do have as an option. I'm heading a technical support team, and we've got all the way an end-to-end support mechanism, so all the way from a pre-sale / design perspective support down to an after-sales and a solutionize into any issues that we develop. So people in the industry can reach out. These are services that are free of charge, supporting obviously code and applications. This is more specific to ourselves, but other manufacturers do have these opportunities as well. So it's a combination of both, but getting in touch and engaging with the product owner or the manufacturer is absolutely key. So a part of technical support that's actually important for us is try to understand how we can benefit the education of our customers and whether we need to make a recommendation for any training material, any training modules that we've got available. So it's just a matter of getting in touch and understand that we're all on the same ship on this one. We just need to make sure that we're going to be delivering successful applications. So we're definitely in the same team.
I just want to clarify, you said ship.
Ship, yeah.
I just wanted to make sure. Has anybody got a final question? Because I'm going to draw this to a close, or a comment you'd like to make. Well, look, thank you, panel. You might want to hang around, because at 12 o'clock, got the MCS coming on here for a chat. She's out her fast car waiting outside. But would you please give it up for our panel? Thank them very much indeed. Thank you very much indeed. So, yes, at 12 o'clock, the new MCS standard for thermal energy storage. What installers need to know? Join us then. Bring your lunch if you want. Come and sit down and have a chat. We'll see you back here then.